Welcome back to our discussion on material science. In our previous lecture, we talked about the importance of understanding material properties. Now today, we will discuss the instruments commonly used for the characterization of these properties. As we know, every material has unique properties that determine its behavior under various conditions. To understand these properties, we use various instruments that allow us to analyze and measure them. By studying a material's properties, we can determine its suitability for specific applications and how it will interact with other materials. Instruments such as microscopes, spectrometers, and thermal analyzers help us gain a better understanding of the physical, chemical, and mechanical properties of materials. Now, this knowledge is essential for designing new materials and improving existing ones for a wide range of industries, including aerospace, construction, and electronics. Now, the first instrument that we will discuss is the ultraviolet to visible to near-infrared spectrometer, or known as UV-Vis NIR. This instrument measures the absorption, transmission, and reflection of ultraviolet, visible, and near-infrared light in a material. It is commonly used to determine the concentration of a solution or to analyze the electronic transitions in a material. The UV-Vis NIR spectrometer can also be used to study the purity and stability of a material as well as its reaction kinetics. It is widely used in fields such as chemistry, biochemistry, and pharmaceuticals, where accurate measurements of light absorption are crucial. In addition, the data obtained from a UV-Vis NIR spectrophotometer can be used to identify unknown substances and to monitor the progress of chemical reactions in real time. The next instrument is the Fourier transform infrared spectrometer, or known as FTIR. This instrument measures the transmission and reflectance of infrared light in the material. It is used to analyze the functional groups and chemical bonding in the material. FTIR spectrometers can provide information on the composition, purity, and structural properties of a material. They are commonly used in fields such as polymer science, materials engineering, and forensic science, where the identification and characterization of unknown substances are essential. Additionally, FTIR spectroscopy can be used for non-destructive testing and quality control in industries such as food and beverage, pharmaceuticals, and electronics. Now, photoluminescence spectroscopy is another instrument used to analyze the optical properties of a material. It measures the light emitted by a material when it is being excited with a specific wavelength of light. This technique is commonly used in the study of semiconductors and luminescent materials. Photoluminescence spectroscopy is a powerful tool for studying the electronic properties of materials such as band gap energies, carrier lifetimes, and defect states. Furthermore, it can also be used to investigate the structural properties of materials such as crystal defects and impurities. This technique is widely used in fields such as solid-state physics, material science, and optoelectronics, where the understanding of light and matter interactions is crucial for the development of new devices and technologies. The X-ray diffractometer, or XRD, is an instrument used to analyze the crystal structure of a material. It measures the diffraction of X-ray by the atoms in the material and produces a pattern that can be used to determine the crystal structure and identify the phases present in the material. The XRD is a versatile technique that can be used to analyze a wide range of materials including metals, ceramics, minerals, and pharmaceuticals. It is particularly useful for studying the atomic arrangement and crystallographic orientation of materials, which can affect their physical, chemical, and mechanical properties. XRD is widely used in material science, geology, and engineering, where understanding of crystal structure is essential for the design and development of new materials and devices. The Field Emission Scanning Electron Microscope, or the FESM, is a very powerful microscope that allows us to observe the surface morphology of a material with high resolution. Now, it uses electrons to create an image of the surface and allowing us to study the surface features of a materials in detail. The FESM is widely used in various fields such as material science, nanotechnology, and biology, and has contributed significantly to our understanding of the physical and chemical properties of materials. With its ability to provide clear and detailed images, the FESM has become an indispensable tool for researchers and scientists in their quest to explore the micro and nano world. Now, the transmission electron microscopy, or the TEM, is a highly advanced microscope that is widely used in material science, nanotechnology, and biology. It employs a beam of electrons to create an image of the internal structure of a material, thus allowing us to observe individual atoms, study their arrangement, and investigate various materials' properties. TEM also can be used for chemical analysis, providing information on the elemental composition and bonding of materials. With its high resolution and versatility, TEM has become an essential tool for understanding the behavior of materials at the nanoscale and developing new technologies with unprecedented precision. Thermogravimetric analysis, or the TGA, is a powerful technique that offers a wide range of applications in material science, chemistry, and engineering. It allows for the precise measurement of the mass changes of material in response to temperature, pressure, or other environmental conditions. This makes a TGA a useful tool for analyzing the thermal stability, degradation behavior, and composition of materials, including polymers, composite metals, ceramics, and biomaterials. Additionally, TGA can be combined with other analytical techniques such as mass spectrometry or infrared spectroscopy to provide more comprehensive information on the thermal properties of materials. As a result, TGA has become an important tool in research and development for a variety of industries, including pharmaceuticals, food science, and materials manufacturing. Now, differential scanning calorimetry, or DSC, is an analytical tool used to study the thermal properties and behavior of materials. In addition to measuring the heat flow in a material as it is heated or cooled, DSC provides valuable information on the phase transition and thermal stability of the material. DSC also can be used to determine the specific heat capacity, glass transition temperature, and melting point of a material. Furthermore, DSC can be utilized to study the kinetics of chemical reactions, polymerization, and curing processes. It is a widely used technique in various fields, including material science, chemistry, and pharmaceuticals. Now, a rheometer is a versatile instrument that enables the measurement of a material's mechanical properties under various conditions. It can measure viscosity, elasticity, and deformation, providing insights into the flow behavior and deformation mechanism of complex materials. Rheometry is particularly useful in studying the behavior of polymers which can exhibit complex and non-linear rheological responses. By manipulating the testing conditions such as temperature, shear rate, and frequency, the rheometer can reveal valuable information on the material's processing, structure, and performance. Moreover, the rheometer can be used to characterize the mechanical properties of various materials, including gels, colloids, fluids, and soft matter. In conclusion, understanding the properties of materials is critical in material science, and the instruments discussed today are essential for the characterization of these properties. By using these instruments, we can study and analyze materials at micro and macro level and design new materials with specific properties for various applications. Thank you for joining me today, and I look forward to exploring more of the fascinating world of material science with you.